Hey, good morning, everyone. So, we're going to do a quick review on Aerospace 3 Chapter 2 Section B quiz that we took, and I hope this helps you guys out a little bit. On this quiz, we talked about systems, so we're just going to jump right in. We talked about uh, what a dual ignition system was, and what that is that it just means that every cylinder has two igniters per cylinder, or spark plugs if you want to use slang. But what that means is if we had a 4-cylinder engine, that there would be 8 igniters, 2 per cylinder. And there are two reasons why we have a dual ignition system. The first reason is for safety. If one of those were to go out, the other one will still continue working. The second reason is that it gives us a more improved engine performance, because when you have two igniters on both sides of the cylinders, they're going to burn the fuel more evenly. So that's the purpose of that. We talked about problems with a fuel system is that there are two major problems we will talk about really fast. Is we will talk about what the we're going to talk about what the uncontrolled firing of a fuel air charge is in advance of spark. So we have the 4 cycles, the suck, squeeze, bang, blow we talked about in class. But if you have a firing in advance of the spark when it's supposed to happen, that is called pre-ignition, and that is usually caused by a piece of carbon having fallen into that cylinder that's extremely hot. So whenever it happens in advance of spark, it is known as pre-ignition. The second thing you can have is known as detonation. And what detonation is it is usually associated with using a fuel that is lower than required, because the fuel is unstable. When it enters into the cylinder, it just uncontrollably explodes for no reason. It was not ignited, and it just blows up because it's not made to handle the temperatures inside the engine. So please use the correct fuel. Also, when it comes to fueling, we're going to talk about when it is good to fuel an aircraft. So it is standard procedure to fill the fuel tanks at the end of the day, because what we're trying to do is we're trying to prevent moisture condensation from getting into the fuel tanks. Because if you can get moisture, you can get microbiological growth, and that is how you contaminate the fuel, and that is a very dangerous thing. So we're going to talk about how to cool that engine. So, like cars that most people drive, they are what's called liquid cooled, which just means that there is radiator coolant flowing around the engine, keeping the engine cooler, because engines get extremely hot. But in our airplane, we are primarily dependent on cooling from the big propeller in front, or the air circulating around the engine, and that's how we externally cool that engine. But for internal cooling of that engine, we are extremely reliant on oil, because the oil is coming up and getting pumped through an oil pump and circulating through that engine, and it's acting just like a coolant, and it's helping keep friction down. Okay. We're going to talk about fuel. So if you go to an airport and you use what's called 100 low lead fuel. And you notice that they are out, but you, for some reason, have to fly. The substitute that you are allowed to use is you are allowed to go to one higher level of fuel. You use the next available grade. You do not ever use the lower grade because that is what causes detonation. So it's kind of like saying that your car runs on, if you have a car, if it runs on mid-grade fuel, you can use premium, but do not use regular. Okay. All fuels are colored. So the fuel color I want you to focus on is the color blue, because that is the color of 100 low lead, and that is probably the fuel you will be using when you start flying. Now, like we said, that engines can get extremely hot. So you need to understand that most energy produced by that engine is actually lost to heat. The number that we are looking for how much is lost to heat is about 70%. So only 30% of that energy created by your engine is converted into actual useful work. Another thing we talked about is the different types of landing gear. We have 3 types. The first type we are going to talk about is conventional, and that is the type of landing gear you would expect to see on like the Red Baron plane, an older plane. So what a conventional landing gear is you have 2 main landing gear and a third gear on the tail, and that is conventional. The second type is called a tricycle landing gear, and that is 2 main landing gear and 1 on the nose, and it looks like a little tricycle. And the third one is called tandem, and that is the type of landing gear that big airliners use. And what that means, tandem means, is that you have 2 wheels side by side on each set of landing gear. If you notice, like a really big plane may have 4 to 6 wheels. Those wheels are in tandem. Okay. So moving right along, we're going to talk about carburetor icing. So believe it or not, just because the weather outside is above freezing, you can still have ice form in your carburetor and make your engine stop. So the key numbers you should think about are anywhere between 20 degrees and 70 as high up as 70 degrees Fahrenheit with high humidity, because when the air gets sucked into that carburetor at 70 degrees, it can still drop as much as 50 degrees, and 70 minus 50 is 20 degrees, and so ice is created at 32 degrees. So always be cognizant of the conditions you're flying in. Anyway, I hope that this little review helps you, and I hope to see you all do well.